In example 4c, the function we are going to evaluate is k of x is equal to the square root of x plus 4. So if you look at our two evaluations that we're going to do, in part 1, we're going to try to form negative k of x, and in part 2, we're going to evaluate k of negative x. So if you remember from example 4a, we looked at both of these scenarios, what the difference is between having the negative sign outside the function and then inside the parentheses. Okay, so remember, if you're looking at part 1 here, what negative k of x means, this is going to mean negative 1 times the function. Okay, so we'll come back and do that. And then the difference is in part 2, if the negative sign's on the inside, in this case, because the negative sign is inside the parentheses, we know that whatever's in parentheses, that's what we're going to replace x with. So here, you're going to replace each instance of x with negative x. Okay, so you absolutely have to know the difference between these two things. Okay, what it means for the negative sign to be on the outside versus what it means for the negative sign to be inside the parentheses. Okay, so now that we've refreshed our memories on that, let's go back to part 1 and actually do this. Okay, so if we're trying to find negative k of x, all we're going to do is take negative 1 and multiply it through the function. So the function is the square root of x plus 4. It has two terms, the square root of x and the positive 4. So we need to encase the entire function in parentheses because we're going to have to distribute that negative through. Okay, so here we've set it up, negative 1 times the function, and now we're just going to distribute this negative 1 here and here. Okay, so we're going to get negative 1 times the square root of x, and then we're going to do negative 1 times positive 4. That's going to be minus 4. Okay, so how do you simplify this? How do you write negative 1 times the square root of x? Okay, well, if you're thinking about this, just think about what happens when you multiply by a number. Okay, so again, if you had negative 1 times 2, for example, okay, you can write this as just negative 2. You keep the 2 and you just put a negative sign out front. So it's going to be the same thing here. The negative sign is going to go out front. You're going to keep the square root of x and then put the negative sign out front. Okay, so that's how you handle this piece, and then don't forget to tack on the minus 4. Okay, that minus 4 is not inside the square root, so make sure you write it such. Okay, so here is the final answer. Okay, all right, so now let's move on and take a look at part 2. Okay, here we actually need to replace each instance of x with negative x. So k of negative x is going to be, we're going to go back to our original function. Everywhere we see an x, we're going to replace it with negative x. So under the square root, instead of having x, we're going to have negative x. Okay, and then don't forget to tack on the plus 4. Okay, now, can this be simplified? Okay, the answer is no, there's not really anything you can do with this. Okay, so this is going to be your answer here. Okay, and I'm sure some of you may be concerned about this particular answer. Okay, why is that? Because, well, you've always been told that you cannot have a negative, or you cannot take the negative, you cannot take the square root of a negative number. Okay, so I'm sure some of you are alarmed by this negative sign being under the square root. Okay, well, let me ask you this. Okay, what we have formed is correct. Just hear me out. Okay, this is the square root of negative x plus 4. Okay, so you get to pick what you choose for x, what gets plugged in for x. So if x is 1, positive 1, okay, plug it in. Okay, so this is going to be the square root of that negative sign is already there. X is positive 1 plus 4. Okay, this would be undefined. Okay, you can't take the square root of negative 1. Okay, so this would be undefined. So don't automatically jump the gun and say, hey, whatever I just came up with, it seems mathematically right, but it just doesn't make sense. Watch this. What if instead you plugged in x equals negative 1? Okay, so in that case, if we plugged into this function we came up with, okay, under the square root, you already have that negative sign. And then you plug in x. Well, this time x is -1. Okay, and then outside the square root, we have the +4. Okay, well, what happens here? Inside the square root, you've got a negative times a negative, and it becomes positive. So it becomes the positive square root of 1, which is 1 plus 4, and you get 5 as an output. Okay, so this is actually a plausible answer. Okay, even though you definitely could be alarmed by that negative sign being under the square root, this is plausible. The thing is, you have to be careful what you plug in for x. You can't plug in any old x value. Okay, so for example, x equals 1 resulted in an error. It caused us to have a negative under the square root. So you can't plug in +1, but you could plug in -1. Okay, and in fact, you can plug in any negative number here. Okay, if you plug in a negative number for x, the negative would cancel with the negative that's already there, and it would leave you with a positive number under the square root. And so then you could carry out the work. Okay, so this brings us to our next concept. Okay, and that's going to be the idea of domain. Okay, and this is going to be a big topic in algebra. Okay, so we're going to spend some time on it. Domain is basically what is allowed to be plugged in for x. Okay, so if you're given a function, there may be restrictions on what you can plug in for x. Like in part 2 here, we could only plug in negative numbers or 0 for x. You can't plug in positive numbers for x because that would result in an error. So our next topic that we're going to tackle is you will be given several functions and asked to find the domain of each function. And domain, again, is all, you have to write down all the x values that are allowed to be plugged into the function. Okay, you can't just write 1 or 2 things that you can plug in for x. You've got to concisely write down every single number that you can plug in for x, and it will be okay. Meaning, I want to write down every x value I can plug in that will result in me getting an output. Okay, so you're going to be excluding the bad guys. Okay, so that's kind of the idea of domain. So let's go ahead and take a look at it.